Okay, so here we're given the straight line y equals 2x plus 3, limited to the interval 1 to 4, and we're going to revolve that uh, region that's generated there about the x-axis to generate a solid. And we want to find the surface area of that solid. So first let's just draw a rough picture here. So we can see what we're dealing with here. All right, so at 1, 2x plus 3 would be equal to 5. And then at 4, 2x plus 3 would be equal to 11. So I'm just going to come up here and say, here we are. And we'll label that point up there as x equals 11. Okay, so we're looking at this straight line. And that's revolved. So of course this is just a frustum. So we actually could take this equation and figure out when it crosses the y-axis down here, something like that. If I was actually measuring things properly, right, like negative 3/2. I'm sorry, negative 3/2 over here on the x-axis. So then you can look at that cone, find its surface area, and you can look at the bigger cone and find its surface area. Right, but I'm not going to go through all that stuff. We're just going to use the straight calculus here. So our function is y equals 2x plus 3. So we would go in, integral between my limits, 1 to 4, of 2 pi f of x times the square root of 1 plus f prime. In this case, f prime is just 2. So it's 1 plus 2 squared. Okay, so on the outside here, I'm going to have 2 square roots of 5 pi times the integral from 1 to 4 of 2x plus 3 dx. And so we just do our integration. 2 square root of 5 pi times integral of 2x would be x squared. Integral of 3 would be 3x. And that's evaluated between 1 and 4. And so I'm going to kind of leave the square root of 5 and pi out of the mix for a moment and just deal with the rest of the stuff here. So evaluating this stuff here at 4 and 1, then taking their difference and then multiplying that by 2. So plugging 4 in, that would be 4 squared plus 3 times 4 minus 1 squared plus 3 times 1. And that's going to be multiplied by 2 in the formula. And so all that stuff is going to be attached to the 40, or to the square root of 5 and the pi. That way I keep my answer exact. 48 square roots of 5 times pi would actually be the volume of that frustum. Okay? Or not volume, surface area of that frustum. Okay, so pretty straightforward. Again, you could go back, as I mentioned, and extend this line over here to negative 3/2, right? And then you would have your little cone, which has a height radius of 5 and a height of 2.5, and you could figure out its surface area, and then you could compare that then to the cone here that has a radius of 11 and a height of 5.5, because this is going to negative 3/2 on the x-axis. Figure out its surface area, and then take their difference, and when you do, you should get 48 square roots of 5 pi. 48 square roots of 5 pi. Okay, and so there we go. We found the surface area of that solid, that frustrator.